Thanks. Hi. So I'm Katie. I'm going to talk to you today about driving real-world engagement with data and hopefully creating meaningful social interaction. I think it's a unique time right now where more than ever an individual's social and emotional intelligence can dictate success in terms of money, in terms of power, not just friendship, love, or your capability to reproduce. So, according to Daniel Goleman, people with high emotional intelligence are critical to success because they are change agents, they're self-aware, they're empathetic, they're not perfectionists necessarily, they understand the importance of work and personal balance, they're curious and they're gracious. And we are inherently social animals. At the same time, for too long to remember otherwise, we're completely dependent or interdependent on machines for food, for safety, travel, information, business, and even for many people, love and reproduction. So as data and automation and our distance from self-sufficiency continues to increase, we need to make sense of data while supporting our own humanity in some way. So I'm a researcher. My background is in new forms of games and play, usually using networked data or sensors. I teach classes in persuasive technology and designing the human. But I spent much of my career so far creating games, hardware, and kind of social products that find ways to make banal data into interesting and useful interactions, sort of bridging entertainment and utility in new ways. I'll talk about some social designs that encourage us to imagine systems that support or encourage our humanity through play and participation, and they look and feel like many different things. Then I'll show some examples of social engagement systems that translate data, real-time network, social, and sensor data into characters with personalities, emotions, and relationships. And then finally, I'll talk about some trends and challenges that we're faced with today. And like Anders said before, I've kind of been in this space for a while. So 10 years ago, I built an open source network sensor that's still available that you stick in your houseplants, and it allows your plants to make phone calls. The sensors detect moisture level and light level, and the plants were mesh networked, so they were intelligent. They could find out from the other plants if it was worth asking for water or light, if people would help them, or if it was cloudy outside, and they knew who had responded to their needs in the past. Using that information, they could intelligently make those decisions and figure out who they wanted to ask. And they did it in a human voice. So they could call people on the phone, they could tweet, they could text, they could email, and each of them had unique personalities based on their botanical habits and characteristics. I also was a gardener in a kind of former career. So I thought I'd play you an example, just so you know kind of where I'm coming from, of one of the calls you would get if the Scotch moss was in need of a drink.
Hi. This is the Scotch moss plant. I'm in need of watering. Could you please water me until my soil is quite soaked?
And they didn't just call to nag you. If they did get watered, you might get a call like this one.
Hi. This is the Scotch moss plant, number 11. I don't know if it was you, but someone just gave me a nice watering. And I wanted to express my thanks. I feel great.
Sometimes they would get drunk. And they gave you meaningful feedback, right? Because it was about the relationship. They were meant to make you laugh, but fundamentally we were kind of translating botanical communication protocols, leaf droop or a chlorotic leaf color, into human social communication protocols with personality, emotion, character on human social channels like the phone and Twitter and all that. And this became exceptionally clear to me one night when I was testing out some different variables, and I was kind of war dialed at 2 a.m. until I could wake a janitor up to unplug the sensor, which was like locked in another building across town. And I had a lot of intense experiences that evening with that imaginary personality. So besides hardware, I helped start, run, and lead a game company called Area Code. We were acquired by Zynga, and I was heading up product there in the High Beta studio in New York. But at Area Code, we made games that explored emerging forms of gameplay and interaction using new technologies and new data sources, inventing new game mechanics and adding levels of unexpected autonomy. So I think it might help us with the conversation we're going to have today and what we're going to look at to just see one or two of these. And if you can think about in the back of your mind the notion of sensors and network data, social mechanics, and unexpected autonomy. So this one was Shark for Shark Week, which is a popular TV event in the States, we used real-world shark location data. So in this game, you would play a virtual marine biologist. It was a online game, and you'd have a boat, and you'd have a team, and you'd kind of name your crew, and then you would set a course for your boat. And this would be the most boring video game in the history of the universe. If you watched the screen, it was meant for you to kind of like make a move and then go away from the screen, and the screen would call you back. This was early appointment mechanics, which ended up making lots and lots of money and being very popular with things like Farmville and Cityville and things like that later on. But like I said, it's happening in real time, so your boat's moving, and then when your virtual ship crossed paths with a shark in the game, the system would text you or email you and kind of call you back. And you would be able to collect data on those sharks and kind of see new information, and always there's kind of the danger of a shark attack, right? So there's a heightened excitement there. And I think that this was the first time that, shark telemetry data, these are satellite and pop-off tags on dorsal fins of sharks, that it was used to autonomously like interrupt meetings and people's bike rides to kind of text message players and get them to log in and kind of do a dive and collect data. And it can be for truly, truly boring data. So shark data is kind of exciting. We use data that looks like this. This was traffic data from locations across the UK. And we used that for a massively multiplayer online game so that this and the behavior of buses like this could control monsters like this. And this was a role-playing game for children to reinforce proper road safety and crossing habits. And through the kind of core compulsion loop that they went through over and over again, and through the social reinforcement, they were able to kind of like put those rules into practice. And the data came to life through the monster characters and their behavior, which is something that kids are infinitely wise at recognizing. People are really, just like it's easy for us to see a face in some holes in the wall, it's also easy for us to kind of like anthropomorphize or throw a character or personality onto data. And we'll come back to that. And then the last example I wanted to talk about was for New York's Museum of Modern Art. We were commissioned to create a game, and this was using players' genetic data. So based on your unique genetic data, we would generate a unique deck of cards for each player, and it's a two-person competitive card game where you're building networks, collecting points, and in the process kind of exposing things about your own genetic makeup. And this is a kind of social scaffolding for people to have a discussion about. It's not just kind of the hand you're dealt, it's how you play it, right? This notion of nature versus nurture and what your role is, but also creating a kind of social mechanic around it that makes it acceptable to have that discussion. Okay, so we've looked at sensor and other kind of network data. We've talked about motivation a little bit through social mechanics and gameplay, and covered a bit of autonomy, like plants making calls and sharks that text you. Today we're talking about driving real-world engagement through data. So what can that look like to consumers trying to manage a complex ecosystem of their smart fridge, their interoperability of their stove, and their in-laws coming over for dinner, and their calendar, and all that stuff? That's kind of been my interest for a long time, and it's why I built something called the Sentient Data Server. It is an experimental service that enables designers and developers to kind of bring sensor or networked data to life using character design, relationships, and emotion. And we'll look at some of the work that has been built on top of it. So one example, this is a first prototype that we built on the service using government data. It's called Here New York City, and it is a system that translates civic data, again, coming back to boring data. So this is non-emergency 311 data, things like rat reports or traffic light outages or fire hydrants that are running or incessant ice cream trucks that are bothering you in the city. And we convert that into weekly procedurally generated New Yorker-style cartoons for your neighborhood that are available on Instagram, Twitter, or email. So what we were looking at, right, if Here New York isn't there, these are the services that exist. This is, you would have to know where these platforms were. You'd have to know how to read these charts and graphs and have the time to do that. They'd have to be running at the time, be up. And that often excludes citizens who may or may not know how to navigate that information or make sense of that information or even know how to kind of navigate through it. So the idea of Here New York is to take one of the most banal civic complaint data sets and make it legible and meaningful at the human scale by inserting it in a playful way into people's social media streams. So that if maybe you live in Bed-Stuy and you work in Lower East Side, you can subscribe to those Twitter feeds, and then once a week you get this procedurally generated cartoon that the machine makes after processing it through the sentient data server, and it kind of gives you an opinionated view on what the issue is for that week. So in Bed-Stuy that week, it was there's a woman, a jogger, running away from an ice cream truck saying stalker. So this is incessant ice cream truck complaints. And here we have traffic signal problems. And the idea was to have it be lightweight, casual injection into people's social media feeds. And if it's interesting enough or they want to find out more about it, then they can click through and find out more through the site, where it's a kind of glanceable, complementary data. It includes like year-over-year stuff. You can kind of compare neighborhoods to each other, and has other information about the education, socioeconomic information, crime for that neighborhood. Because obviously government data is really important. There's a huge open gov movement, but if the people who are making the decisions aren't able to understand it or interact with it, then we're leaving a lot of people out of the conversation. So this was really an experiment in how we broaden the reach and breadth so that the people who are have the opportunity to vote also understand the situations. 311 data in particular is not ground truth, it's a complaint. So you can imagine that maybe the people who have the time and the means to make a complaint may not be the people who are having the biggest issues. And then all of it had a quick click through to kind of get involved with the community board. So let me run a little bit faster. I run something called the Humanizing Data Research and Prototyping Group at NYU's Interactive Telecommunications Graduate Program. The challenge there was what kind of new applications can you imagine and build when data is interpreted in terms of emotion, relationships, and personalities. So I want to show you a quick video of some of the work. This is a reactive room. It's using audio and presence sensors and encourages collaboration and comfortable co-working environment by autonomously shifting screens or introducing white noise. So the system recognized was agitated because he was being so loud, and it kind of shushed him. And in this one, you have, this is powered by a real-time feed of street-level activity data. This is self-aware traffic lights that autonomously display data-driven content in attempt to keep people safe by asking people not to jaywalk, and it has emoticons and provides on-demand positive messages. And these are a set of self-aware bikes that are networked to New York City's City Bike Share program. They have tails that express if they're happy to see a new user or alert, and they're motivated to get themselves distributed across the City Bike hubs where they're needed. And flirtatiously, when they are next to another City Bike, they'll kind of sync up and play music and hopefully give people an excuse to talk to each other. And this is a dynamic public map that expresses shame. Oops, we ran through that. Sorry, it's a dynamic public map that expresses shame, and it hides or reveals itself based on 311 data. So it hides neighborhoods. And using location, biometric, and calendar data, the Sentient Web is a service that tells third-party apps when and where to reach a user on the social stack: email, text, phone, direct messages, using emotion as a proxy to protect users' privacy. So the through line is a sentient data server. It's an underlying reusable infrastructure. It's a server and a REST API that powers all these things and enables third-party designers and developers to use character design to afford new kinds of interaction and experiences. And the hope is to really take kind of complex, multidimensional information and use characterization as a single vector to communicate and interact with that information. And what I'd like to kind of close on is that with these new modes of interaction creates new challenges as well. So along with all these fun things, our challenges around social etiquette, negotiating consent and privacy, the ethics of data collection and transparency, overloading communication channels, efficiency versus complexity. And if you look back at these examples, for example, the self-aware street sign could be built using the publicly available traffic cam feeds for near real-time analysis for auto and pedestrian issues. But how do we navigate kind of the permissions for pedestrians about who's monitoring these streams and what's meaningful social etiquette for signaling them? And in this example, like, who's defining shame? There's a public map that's expressing shame. So the designers are making critical decisions about shame, but who says who gets to determine that, and what's the feedback loop? There's issues with silencing data if you're hiding messages from people. And in this one, we're talking about negotiating consent, pushy architecture, and again, more challenges with social etiquette. So I would love to wrap up, and I think the opportunity here is that interfaces that use human social cues and protocols have an immediacy and an accessibility, and every design choice can meet us where we are or force us into a machine's expectations of how we should think, act, and be. And the real question is, how can we make more human systems? Thanks.